It depends on our next speaker, really, no pressure. But I want you all back here at 3 p.m. So, okay, I need to do some switching on the computer. This might or might not work. Damn, I'm already lost. Kostas? Yes. So, Igor is an engineer from Moscow and he works at Clean. He was one of the first people to work with a very cutting edge technology like ROM and DryRB in, I would say, production, because why not? If you do it anyway, do it in production. And he will tell you all about it because he cannot stop talking about it, I've heard. So there you go.
Well, hello everyone. My name is Igor, and I'm a software engineer from Moscow. I work at Clean, and my primary job is related to Ruby, but I also have some commercial experience with Python, JavaScript, and Reason. And I've come here basically to confess. I've come here to confess that I don't trust myself. And it's not some kind of insecurity issue, as you might think. I just don't trust myself because I know that I'm a software engineer who makes mistakes. And there are 4 reasonable explanations to not trusting myself. Well, the first one is undefined is not a function. And that's practically the reason I can trust myself. You see, sometimes, especially in dynamically typed languages, I expect a variable to contain something and it just doesn't, you know. And the next reason for not trusting myself is n+1 errors. So I used ROM for over 2 years, and that's practically all my prior Ruby experience. And when I switched jobs and had to work with Rails, I realized that n+1 errors are real and that I have to be extra careful about it. But I really just can't be sure that I will never forget to include something, and well, sometimes I just make those mistakes. Then we have some complex domains. We have a lot of conditions. We have some really complex domains, especially in enterprise application design. And sometimes it's really easy to mess things up. And like, I can send a cleaner from Moscow to clean an apartment in St. Petersburg. And those things happen. Thankfully, we get rid of them early. And so the first reason I don't trust myself is sometimes I make silly syntactic errors. Sometimes I forget to close a bracket, sometimes I add an extra one, sometimes I forget about quotation marks and whatever. And the last reason is I forget some details. There's always something small, like I don't know. There's just so many details in each of the tasks that I just can't handle it. So I make mistakes, and to actually deploy working software, I have to double check myself. And one of those solutions I've realized I can use the right tools. And I already use things like code review. I have linters, I have manual testing, I have automated tests, but I really don't think that is just enough. I want something more. And what I really love about programming languages is that it's already a tool. A programming language is a tool that we can use to build the right code. And so I use Ruby's type system to make sure that my code works correctly. And before we start talking about types and stuff like that, we have to answer one question, like, do we really need to care about types in Ruby? You see, Ruby is a dynamically typed language. It doesn't have type annotations, and thankfully it won't. But why do we really have to care? And the answer is yes, we actually have to care, because dynamic typing is not really an excuse to be reckless about our customers' data. Like, it's practically our job to keep the data safe and transform it and store it. And we don't want anything to go wrong with it. And you know, Rollbar has recently published a report where they analyzed over 1,000 Rails applications and collected a list of the most common errors. And I've counted, and 2 out of 10 the most popular errors are related to types. One of them is trying to iterate over a nil, and the second one is trying to get an ID of a nil. And you see, those errors are not really significant. You get an exception, you fix it, and you move on. There's nothing really better. There's nothing much of a drama here. But what we really have to avoid is silent data corruptions. And one of the recent cases from my practice, from some other people's practice, is JSON field in Rails. Like, you see, a while ago you could just put your JSON into a string, you could just serialize it and put it inside a model. And the model will just try to parse it into a hash. Now, you can't do that. Now, the library just won't let you do that. And apparently, some people haven't noticed that little detail during the upgrade, and neither did we. So some data might have been corrupted. Thankfully, well, we noticed it early and fixed it. But you see, I want to prevent those kind of errors. And to do so, we have to use the right libraries. And when I'm talking about the right libraries, I don't mean anything like code review, like I don't mean specs, I don't mean code coverage. Especially I don't mean code coverage because, well, even a perfect coverage won't help you avoid those mistakes. What I'm talking about are tools to build our code, like libraries, frameworks, stuff like that, because I believe that writing a good code is really easier than fixing it. And when we talk about types, especially in terms of Ruby, we have to consider that every object has a type, like literally every object. And when we talk about data types, we have to ask ourselves, what is actually a type? And thankfully, in 1976, professors Parnas, Shore, and Weiss actually published a paper where they analyzed a lot of usages of the term data type, and they gave 5 definitions. They considered syntax, value space, behavior, and representation of a type. But I think that the most useful of them is about value space and behavior, and it says that a type is just a set of values that a variable can possess, and a set of functions that one can apply to them. And if you think about it, it's probably the most, well, intuitive way to think about types, because when we have an integer variable, we know that it only contains numbers like -1, 0, 10, 11, 1000, and so on. And we know that we have a limited set of functions that we can apply to those numbers. Like, we have subtraction, addition, multiplication, we have our own built methods, like, we can do a lot of things with those integers. And the good thing about this definition of a data type is because we learn to consider all possible values. And, you know, if we considered all possible values of a variable, we really could have avoided those mistakes from the Rollbar report. Those mistakes happened because developers were not really accurate when they were passing data around, and practically those errors happened because we tried to call a function that doesn't work with nils on a nil value. And what we also have to realize about nils is that it doesn't belong to every type. Like, if you have an integer, you don't have a nil. Languages like Java teach us that every type has a special value, which you have to always treat specially. You can't really use nils unless, well, you can't really use nils the same way you use objects, like the same way you use arrays, strings, or anything like that. And I believe that one of our tools that probably most of us use every day is evil, because it teaches us to be reckless. When we use active support, it teaches us to be reckless about nils. And what I'm talking about are those two methods. Active support adds methods called blank and present, and those methods teach us that a nil and an empty string, an empty hash, and an empty array, yes, that those things are the same, like, and that's just not true. Like, you can say that an empty string and a nil are the same in your semantics, like they are semantically the same, they don't contain any valuable information. But in terms of types and the way you treat this data and the way you write your code, those things are different. So you don't have to believe me that you don't really need blank and present, but what I really urge you to do is to try and remove those methods from your code. And it's really not just about removing the string. Well, the first obvious thing to do when you have to remove those methods is to replace them with the similar checks. And I'm not really asking you to do that. To fully remove those methods from your code, you have to think about the design of your data. You have to reconsider the design of your whole application flow. And once you've done that, you'll realize that you constantly asking yourself a question like, why can this variable be nil? Like, do we really have to call this method if a variable can be nillable? Or the bad thing about blank is that it believes that an object can be empty at some times, and we'll have to always ask ourselves the question like, can this object ever be empty? Does it even have a property of emptiness? And once we've rewritten the application without active support, or at least those two methods, it's likely that our application design will be better. But you know what? Just being careful is not enough, because I really can trust myself not to make those silly type mistakes again. So whenever I have to write types, I need some tool that will tell me that I'm wrong. And it would be great to have some kind of type inference and stuff like that, but unfortunately Ruby doesn't have it yet. So I have to use libraries like dry types. And this gem is actually a simple and extendable type system written for Ruby, and it's written in Ruby. And probably the best thing about it is it just works. Like, you see, if I have a string variable, I make sure to use the right constructor for it. Like, I have to only use it once. And the best thing about this kind of approach is that the library will tell me that I'm wrong. If I ever manage to pass anything other than a string, it will tell me. It will just warn me that I messed up. So it will be really safe to design my application around that kind of code. And if I'm really sure that I need this variable, I need the string to be nillable, I'll just use another constructor that lets me use nils. And I use dry types even when I have some complex definition, like enums, like if I have an array or if I have schemas with hashes. And probably the best thing about dry types is that it really won't change your architecture. It's just a library that lives on top of your application, and it's really up to you to describe your data. You can even completely remove this gem, you can completely remove those definitions, and it will just work. But the thing is, if you really want to feel the power of dry types, you should probably use things like Hanami. Like, it uses a lot of definitions from dry types, it uses a lot of dry gems, but if you already have a huge application like I do, you should probably use dry types in your domain models. Like, the first step to a type-safe Ruby application is describing your data. Like, every object always has some kind of a schema. So the primary goal for us when we add static type into our program is to describe our data using dry types. Then we have to use those definitions in data constructors, and if we really have mutable data, we can just go and add those definitions to the constructors. But if we're hardcore enough, like if we're really brave, then we can just rewrite everything using dry struct. And so there are 3 ways to type safety in Ruby. The first one is actually you have to stop using some features of active support because it really hurts our code. Then if we want a type-safe application that will never crash, and well, it will crash, and if we want a type-safe application that will prevent us from messing up with our customers' data, we have to consider all possible values of a variable. And probably we should use strict constructors to avoid making those mistakes. So strict constructors help us. Strict constructors tell us that we messed up. Now, any language like with a great type system helps you express errors. And Ruby is not an exception to that. Like, we have different ways to express errors in Ruby. Like, we can use exceptions. We can use return codes. Like, you use. If you write C, you might have noticed that those special return codes. We have return codes like in Unix, but result objects are just another way to express errors in a language, and they have been getting more attention lately. And that's really good because Ruby's type system is flexible enough to express our errors using just types, and result objects actually teach us that errors are not really exceptional in our application. In real life, errors are practically everywhere. We have a lot of complex processes, and basically a lot of things can go wrong. And result objects teach us to consider them. Result objects teach us to design our application to handle them, to recover from it. And a good thing is that types actually facilitate error handling. But there's one thing that feels wrong about result objects. It would be really great to have some kind of universal result object. Because you see, if you decide to make your own result object for every project, you'll eventually realize that one of the first things you do when you start a new one is practically building your own result object. Like, you have to master building result objects just for the sake of result objects. And I believe it would be great to have some kind of universal abstraction for that. And thankfully, we do. We actually have a mathematically sound abstraction for result objects. What I'm talking about are monads. So, monads are a fairly old concept from category theory and functional languages like Haskell, and they work really well in Ruby. And if I ever try to give a definition to what a monad is, I will most likely fail. In some fashion, monads are similar to musical instruments because, you see, there are just so many of them. Like, there are literally, well, there are several monads, there are hundreds of musical instruments, and if I ever try to give a comprehensive definition which will be factually correct, I will never succeed. So I will not try to be correct, and I will just say that a monad is just a result object with a few rules. And we have a gem called dry monads. It contains a lot of monads. It can provide some useful ones, like either, maybe, try, and task monads. And those are really deep topics, so today I will not really I won't even try to cover everything. So today I want to talk about just one of them, a result monad, also known as either. So a result is a composite data type that consists of 2 subtypes. Like, it can be either a failure or a success. Practically, in practice, those failure and success are actually containers for some kind of data. And what we have to realize is they are containers for different kind of data. So to use the result in your application, all you really have to do is to install the gem, require it, and use the constructors. Like you have a success, you have a failure, and that's practically it. That's enough for the most cases. No need to reinvent the wheel. But you know, monads are a hot topic in functional languages and category theory, and there's a lot more to monads than just being data containers. And what we usually talk about when we're talking about monads is that monad is a computation context. It helps us build data transformation pipelines. And one of the methods that help us do that is bind. So a bind practically takes a block and applies it to and calls it on a success. So if we have a value which is wrapped into a success, then we will just unwrap the value and pass it to a block. And this block really has to include, it has to return the same monad. Like, the best thing about bind and stuff like that is that it only follows the happy path. It helps us design our application pipeline in a type-safe way, and it helps us really think about errors. Like, if there was a failure, then we will just halt all further execution, you know. And the problem with this, the possible problem with this method is that it doesn't work with failures. Like, we have to find a way to chain methods for not so happy paths. And we have a similar method for failures. We have a method called OR. Practically, bind and OR are the same, except bind does nothing on a failure and OR does nothing on a success. And you know, the problem with those two methods is that, well, first they have to always return a monad. So if you have a huge application which is not built around monads, then you really can't enjoy using them because, well, you know, you have a lot of code, you have to write a lot of monadic boilerplate. But fortunately, we have a way to use non-monadic code with monads. And that's a method called fmap. It's practically the same as bind, but it will just wrap the value back into success. So we can just use Ruby's built-in methods. We can use our own methods from which are not aware of the existence of monads, and it will just work. So, but all monadic computations happen inside some kind of context, and the problem is we're in Ruby, we're not in Haskell. We really have to eventually escape the context. And we don't have pattern matching or something like that. So we have a method called value OR. Practically all it does, it's similar to a method fetch on a hash. Practically all it does is it unwraps a successful result. It gives, or if it's a failure, you can just pass a block and it will return a default object. It helps us design our applications in a really type-safe way. We can just assign a variable. We can just use a pipeline with a lot of binds, a lot of ORs, and at the end of it, we will just try to unwrap it. And when we do, we are sure that we will always get a predictable result, and that's good. But sometimes we don't really care if it's a success or a failure. We want to unwrap it. We want to get an error message. We want to get something like that. Then we can just pass an identity function to the block. You see, Ruby, like many functional languages, also has an identity function. Practically every object has a method called itself, which returns itself. That's practically the whole point of the identity function. So if you don't really care about type safety or you don't really care about what the result of the monadic computation was, you can just pass the itself to the value or. But you know, when you have those chains of computations, they can get really ugly. Like you have a lot of nested values, you have some weird pipelines, you have a lot of naturally we have a lot of if conditions, we have cases, we have different things, and that's not really a pleasant journey using monads. So we have a solution for that. We used to have things like dry transaction, we used Trailblazer, operations, DSL, but now we don't really need those things. We can just use plain Ruby, and that's great because we now have a concept called do notation. The name is actually borrowed from Haskell, where do is actually a keyword and it's part of the syntax. So now we can just yield the variable. We can have a class with a method. We can wrap it using do notation, and we can just yield monadic values. Like you can see on the slide that we have a few methods called find by name and find contract. And the thing is, those two methods are expected to return a result. And whenever those methods return successes, do notation will automatically unwrap the value. And that's really convenient because we still have our own Ruby, we still have the same language we used to, but it really has a really convenient result object. So now, just to recap what I've been talking about. Well, first, types help us design our applications. Types help us design our applications to maintain the perfect, or at least good. Types help us design an application that will just work. We can use types to handle errors, fight our mistakes, and a lot of things. So then active support may be bad for your code. Like there are two methods called blank and present, which you do not really need. Like I've been with Ruby for 2.5 years, and I haven't really found one single place where those methods would be justifiable. And the next point is you can use dry types to design type-safe applications, and it just works. It works really well. And then you can use monads to gracefully handle errors and use them in your application. And I've collected a couple of links. You can find them when we publish the presentations or something like that. So you should check out Hanami if you're interested in those things, or you can just or you just can go to dry.rb page and learn about things like that. And if you're really interested to talk about monads and category theory, you can just send me an email or find me in the hall and we'll just talk. So, thank you.
I have a clicker now as well. I get more and more dangerous by every talk. So, it's a break. I want to see all of you beautiful people back here at 3 p.m. Thank you.